And had a good long weekend if you took some time off yesterday. Before we get started, we'll just make sure that our mics are working properly. So let me know in the chat if you can hear me, and Aaron will test his microphone as well.
Hello, hello. Can you hear me?
Alrighty, got some answers here. Thanks for helping out with that. We'll go ahead and get started. Good morning, everyone, and welcome to today's EnRoute webinar. My name's Bennett. I'll be the moderator for today. Our presenter is Aaron Clapp, Application Specialist at SAi. He knows everything there is to know about EnRoute, and today he'll be walking us through what to do when you have a job that's bigger than your table. After the presentation, we'll be able to answer any questions you have either about this topic or any other EnRoute topic, so feel free to put those questions in the chat and we'll answer as many as we can. We are recording the webinar as always, so if you want to review anything Aaron discusses, we'll be sending you all the link here this afternoon, so look out for that in your emails. And that's it for me, so I'll go ahead and turn it over to Aaron.
All right, sounds good. So we've got our screen pulled up here, and talking about cutting a job larger than your table used to be kind of a little bit of a chore, if not something that could be pretty daunting to do depending on what you're trying to accomplish. Some of the old traditional style methods were to, set up dowels and things like that, and create a design on your screen, and then just shift it over using the move command or something like that, or change the origin of the plate so that the plate would move origin, things like that, which all had worked, but had their inherent kind of problems with them in that you might run into errors and things like that, or you might easily make a mistake in terms of positioning, and then then your cut's kind of ruined. So here, the tool that we're going to look at today is going to be the paneling tool that allows us to cut multiple panels in a bigger job format so that we can take something like a several 4x8 sheets of plywood together and create one big kind of sign. There's a few things you want to keep note of as we go through this, and we'll kind of walk through those so that you kind of know what's going on and what to expect when you see these messages, and kind of go through that whole process. So let's just get something on screen here. First of all, let's start with our plate. I'm going to go ahead and grab this here, and I'm going to make a 192 by 96 size plate here. And that's basically going to give me 4x8 sheets here. And we'll set up our plates here or our divisions here in a minute. So let's go ahead and just design something here real quick. Let's get our text tool. And let's just make this a little bit bigger here. Start out at 10 inches so you can actually see it. No. Centered. All right, now let's convert this over to curves. And I'm just gonna grab this and hold shift until it fills up our space here, and then I'm gonna just pop it into the middle. And then let's just throw a toolpath on this because we'll need a toolpath for this. So let's just grab a routing offset here real quick. I think I've already got my parameters set the way that I want them. Yeah, that's fine. And we'll click OK. All right, so we have a sign here that's going to encompass multiple sheets. And so, this might need to be set up this way, or maybe you're doing some kind of other texture pattern or something bigger like this that needs to be cut. This can apply to pretty much anything. I've seen guys do this for, big pieces of detailing for a large wall, things like that, where you want the pattern to extend and be kind of cohesive and not too repetitive or whatnot, or if you have a unique design that you're doing, whatever the case is, this is a very simple example of this. So the first thing is obviously we want to set up our plate so that it reflects the entire job or the entire finished plate. So in this case, I'm not going to set my job up to be individual 4x8 sheets. So if we just go back to um, this, you can see a regular 4x8 sheet's only going to encompass this little section. So what we're going to avoid is instead of moving this around manually, we're going to say, okay, this is going to fit in 4 pieces of 4x8. So I'm going to make that my size. So that's the first consideration, is making sure that your plate size is the maximum size of the material that you're going to be cutting. Now, this obviously would be a little bit ambitious for, I think, uh, doing something like this. But depending on your router setup, this might be feasible. I think most people are probably looking at something that's a little bit longer than their table, and usually that may only be by a couple feet, depending on the size of table you have. So if you have like a 4-foot table and you want to do something on a 4x8, this would be helpful. Or if you have an 8-foot table and you want to cut something on a 10-foot, then that's where you're at. Or if you have a 10-foot and want to cut something at 12 feet or maybe even longer, that's would be a good example of that. Some machines may not accommodate going vertically as well, but in this case, I just kind of want to demonstrate, how this tool will change the orientation in EnRoute so that it makes this a lot simpler for you. So we all know that when we output this, and I'm going to go ahead and just output this with just a generic multicam driver, just because the code is easy to read. And this will be our sample. I'm going to use a piece of software in the solutions menu called Backplot. If you have any kind of G code that's fairly readable, it's your standard G code style, this application can read that G code and then pull it up in a way that's actually visually readable. So we can see that this is the multicam software. Again, real standard G code. So most of your machines will be able to handle this. Some machines it can't. If the code is a little bit weird or kind of non-standard, it might not read it as well. But the idea here is that I can kind of take a look at some base things. And the things I'm kind of really kind of focused in on here is this view here. We can see that the orientation is the bottom left. And this is kind of where everything starts. Now, your driver is going to be a little bit different per use case scenario. There are some drivers, so some of you might have a custom driver, or for example, the BSEs and some of the other machines out there will have like a flipped axis. So this may not always start in the bottom left, but in this particular case, it does. It might start up here. It might start up here, depending on where the origin is for your machine. And again, that's kind of built into your driver. So when you take a look at this, this is kind of what we'll see in this example. Now, EnRoute's origin is also in this corner. Now, again, you might be designing in this corner, based off of that, but your machine or your driver might be flipping it so that it matches what your origin is on your machine, and that's great. But the important thing is that we need to know and we need to change the origin of EnRoute so that we don't have to do anything. We don't have to move this. We don't have to rearrange it or do anything on the design side in order to accommodate this on your machine. That's the point. So the first thing that we're going to do is we're going to click on our paneling tool. So I'm going to click up here and, whoops, wrong one. I'm my plate settings, and I'm going to hit define plate panels. Now you're going to see this, and I intentionally did this way because I wanted you guys to see this. So this is basically an option here that has to be turned on in order for this to work. It's called clip to plate or clip toolpaths. It needs to be turned on. I can go ahead and say yes, and it'll automatically turn it on for me. I really don't see why you'd want it to be no, unless I guess there would be reasons why you wouldn't. But for this tool, you typically always want it on. So I'm going to say yes, but I'm going to show you where that option is in the preferences. So if we go to setup and we go to Preferences, you're going to go under Toolpath section, and there's this little option for Clip Toolpaths to Plate. This option by default is unchecked. So it looks typically like this. What this option does is this actually clips your toolpath to the plate. So let's turn off our panels for a second, and let's just kind of see what does the clip to toolpaths mean. Well, it's kind of a design style actually, and so a lot of folks will have multiple items on screen. So let's just say maybe they're working on several renditions of this, and maybe changing the spacing, or maybe one was a little bit smaller than the other, maybe at a different scale or something like that. So they had some different variations in here, but they wanted to keep that inside the file. Well, when you go to Output, you would obviously have to select this, click Output, and then choose Selected Only. Well, I don't know about you, but I tend to forget. Happens to me almost every time. I go to review my output file, and then I'm like, oh, no, I forgot to hit selected, and I've output everything on the screen. So that's not good, right? Because this is obviously going to throw an error on your machine if you try and cut this. So that's what the clip to plate does. It says anything that's any toolpath, irregardless of what it's connected to or where it's at, if it goes outside of this boundary, it gets cut off. So if you have this style of workflow where you like to save, variations of the same artwork inside of the same file, you can turn that option on, and you can still have them already toolpaths sitting on the side, ready to swap in and out if you want to. Or if you prefer the other workflow, that works as well. So this is just a kind of a neat, convenient feature to use, but in this particular case, it's actually essential because we're wanting to use our panels. So now that we know what clip to plate does, we understand where it is and how it functions. It's going to cut every toolpath on the outside of our plate. Then we're going to go ahead and turn this back on, and we're going to set up our plates. Now you can do this in two ways. The first thing you have to do is just put your cursor up here, left click and drag, and now we can get a line, and we can just drag this and drop it wherever we want. And we're going to talk about accuracy here in a second. And then I'm going to drag another one from the left hand side. So I just left click on the left hand side of the screen over here and drag in, and then pull it to about the middle. All right, so now I've got different panels that I can choose. What I'm going to do is I'm going to highlight one of these, and I'm going to hit F2. What that's going to do is it's going to bring up kind of like a precision input center of sorts. And this is going to allow me to change the axis of this. So obviously this is in the length axis here. So I want this to be at 96, so right in the middle. Tab, okay, and that'll change that one. And then I'm going to come over here and do it again. Click on this guy, hit F2, and I'm going to change this one to 48. I want it to be halfway in between. Okay. And that allows me to put it at whatever coordinate I want to. So it's really accurate. That way you can put the coordinate or the dividers, wherever you want them to be. So in this case, I've got 48 by 96 or 4 by 8 panels here. And now you'll notice that one of these panels is green. So this panel is going to be the panel that gets output in our software. So let's go ahead and take a look at our panels here. And now when I choose one, I can choose any one and hit enter on my keyboard, and that will select that new panel. This is the panel that's going to get output. So imagine that this green plate or this green area is now your new piece of material, or your new plate, as it were, so to speak. So when we look at this, EnRoute is going to treat this green area as a plate, as your piece of material. So any toolpath that comes outside of this green area is going to get cut off and will get cut in the next piece. So we can kind of see that here. So the last thing that we need to do then is output. Well, before we do that, there's one small change that we need to make. So if we go to Setup and you go to Driver Selection, also, just so you're aware, I'm going to before we get too far or get too deep into this, I want to just briefly mention this for EnRoute 6. If you go to Setup and Preferences, your view is going to look a little bit different. Just so you see here, you're going to see Clip Toolpaths to Plate. So it doesn't have the nice shrunk down view. It's got everything kind of just dumped in here. That option is right here. Just so you know that that's where that one is. It's real similar. And then when you go to select your driver, instead of driver selection, you'll see machine setup. So if you're running an EnRoute 6, just those are the two things that are going to be different, slightly different, just to kind of take note of those real quick. Okay, so back to our driver again. This is not good. It's not going to matter what driver you have. They're all going to be the same. This screen is always going to look the same. You're always going to see these same options. So what I'm going to do is I'm going to go into my driver parameters. I'm going to expand this section. And you might see a few different options here in EnRoute 7 if you're running 6. So you're going to see a little bit of difference, not a whole lot. There's a few options that are added, but what we're really worried about is this option right here, the user defined. I'm going to set this to plate. Now, you could probably leave it at plate and it'll probably never be an issue. But if you're ever concerned that it might cause a problem, you could always switch it back to user defined once you finish doing your table or your job it's larger than the table. And so then you can just switch it back. But it's not going to hurt to have this at plate, because even if you're not doing a panel job, it's always going to put the origin in the bottom left-hand corner here. So it'll be just like normal. It's just the default is always set to user defined instead. So plate is going to be where we want to be. Hit OK. And now we're going to output our first plate. So I'm going to select the bottom left one here just to get started. I'm going to hit Enter. We're just going to output this, and EnRoute's origin is still going to be the same. So bottom left-hand corner, we're going to output this. I don't have to hit selected. I don't have to do anything. I just say all. To file. And then we're going to say this will be section 1. And we'll open this up with backplot here. Okay, so that's our original view. And let's open up sample 1. Okay, so now what we can see here is that our origin is still in the bottom left-hand corner. And then our section, this is what we're going to cut. So that's perfect. That actually matches up with our panel. So we're happy with that, and we're ready to go. So, oh, come on here now. All right, backplot. Coming from another monitor, it does not like resizing. So there we go. Okay. Windows. Okay. So that's great. Now let's go back and let's change our panel. So all we have to do is click on Define Panels. It leaves all of our panels in place, so we don't have to worry about every time we click that. It doesn't change them. We'll click on this one, hit Enter, and we'll just output again. This will be section 2. And then we're going to show something here in just a second as to what happens when you don't choose that option for plate. So let's hit Open. And we'll go to section 2. All right, perfect. So now we can see that EnRoute's origin is still in the bottom left-hand corner, and it's changed it for us. So basically what's happened is, by using this tool, EnRoute has now shifted the origin from this corner up to this corner. So this is now your new 0, 0. And this is important because if you tried to do everything from this corner, you'd be out of bounds on your table. And you'd get errors on your machine saying that it can't do that, and all sorts of problems. So it's important to be able to shift your origin from here to here. without having to move this. That's the important part here. And so we can clearly see that when we look at the output file. Clearly, EnRoute has moved it from down here up to up here, and now we've gotten our E and R and then half of the O. Now, let's go back to EnRoute because it would be kind of nice to see what would happen if we didn't choose the plate option. So if we go in here and we choose just user defined, hit OK. Now it's going to use the bottom left, but it's going to be based on the user-defined plate that we put. So basically the red box. Output again. We'll go ahead and just overwrite that one as section 2. Okay, we'll save it. Let's bring up our back plot and open up the same file again. Oh, let's see here. Open the right one. Oh, I actually spelled them slightly different, I think. That was our problem. I added an extra C. Oh, hold on. There we go. There. Okay. So here's what happens when we don't choose that option for plate. The origin gets shifted down here, so it still thinks the origin is down here. And then it has to move off the table to get to our first cut up here, which we can see starts actually over here at the C. Or the O that's been cut off. And so you can see here that it's nicely chopped off this letter here. So that's good for us. And when we remove the panel, those two things will get connected. But the important thing is that setting. And so that's kind of important here. And that's what EnRoute is doing in the background, is it's automatically moving that for us. So if we go back and change it, we'll look at one more panel. Adjust our panels here. We'll go over here, hit enter, and we'll output again. Section 3. Bring up our back plot. By the way, backplot is a really handy tool to use anytime you want to verify your code or just verify to see what's actually going on. It's a really good option to use. So now we can see here again, it's moved our origin point from here right to this corner right here, which is what we want. So this is going to help make this kind of thing a lot easier. Whether you're doing rapid texture and you want to do really large panels and you want to do this in multiple panels and you want to put them together, that's going to work here. This will work if you're doing large 3D jobs. So if you're doing something big that's 3D and you're looking to cut it up into several sections, this would be a good way to do that. Or if you have just large, long pieces, I've seen this with ceiling decorations and stuff like that, where users were cutting stuff that was like 12, 13 feet long. And so they were cutting huge pieces, but they needed to be in one piece. They couldn't scab them together, or they couldn't put them together. They're too delicate. They need the strength of being one piece, things like that. So this is going to be helpful for that. Again, all you have to do is click on this button. It'll automatically ask you if you want to turn the clip to plate on. You can say yes, it'll turn it on for you. And then just check to make sure your driver is set so that it goes to plate. And then it'll always pick the plate that you have highlighted as the new origin for your current job as it outputs. So this is cutting something that's larger than your table. Again, it doesn't have to be near as elaborate as this. You could set this up to something very simple, to where it's 2 feet extra, if that's all it is. But the important thing is that this makes this a lot easier to do. Now, if you're moving your material, in this case, this is a scenario where we're actually putting on brand new pieces of material, right? So big 4x8 sheets are going on the machine in their hole. if you're going with a 4x8 or a 4x10 sheet, let's say, and you only have a 4x8 table, you're going to want to still work out something on the machine in order to move that piece into the correct position. So this might be helpful to have like some dowel holes to put in, or some kind of way to limit how far you push the piece over. So maybe some limiting pins. Some folks, what they'll do is they'll drill a hole in their spool board. If you don't have pop-up pins or anything on your machine that kind of helps you center something exactly in the same spot, it might actually be helpful to maybe create like a little jig or some little pins inside of your spool board where you can shove something up into that corner and it always is in the right spot, and then do that for both sides. So that might be helpful as well. So the only difference there is you're going to need to shift the material over, but then you don't have to do the same thing in the software. So this will eliminate one step for you, so you don't have to try and match the amount that you shifted it over inside the software and on the table. You just have to do it on the table. So that should help, moving and reducing the amount of errors that you might encounter trying to do something that's a little bit longer than the table, or something that requires multiple sheets of material. And again, we can right click and we can drag these away off screen and get rid of them. So now we only have 2 panels here, and that would be how we could construct, a longer job like that. So any questions on this or anything else regarding EnRoute in general?
Bill has a question. He's asking, where do I find the backplot?
Find backplot. Backplot is in your solutions menu, and it's right here. So backplot is right here. And what's cool about backplot is what I've always find is you can see your code right next to it. So you can actually do what they call a step move. So if I go to view and I go into step mode, it actually deletes everything on screen and only shows me the parts that I've actually executed. So I can use my arrow keys to just kind of mouse through the code, or I could jump to a specific section of code and say, oh, I want to take a look at that right there. And I can kind of look and see what it's doing in every step to verify if I see a problem or something like that. I can kind of verify the code right in here. That is, if you're familiar with reading G code and things like that. Now, you'll also have these other views, which is, this is a perspective. So this allows me to kind of zoom in and look around if I want to. And then we also have the side views. Now, one thing that's a little bit different about the multicam is that the z-axes are actually flipped. So instead of above the material being positive, it's negative. And so it's a little bit weird. So when backplot looks at it, it's actually upside down. So normally that wouldn't be the case, though, because most machines operate normally. But you can actually see your Z plunges. So technically, this is the top of the material, and it's plunging in like this. So you see that there. So you can kind of check your movement, see what it's doing. The red lines are arcs, and then the blue lines are line segments. Now this font has kind of a little bit of a curvature here, so that's why some of these straight lines appear to be curves, or either way it's going to cut correctly. But so red is curves, blue is not, and then the gray line is an above the material movement. So that's just a little bit about backplot. It's kind of a nice little tool. You can go into one view specific if you want to. Step through the code. It's kind of nice just to verify, especially if you're concerned about, hey, how's this job going to look, or does the code, is it going to output what I want to output, kind of thing. It's a nice tool to kind of just visually see what's going to happen before you send it. Also, another good thing this is useful for is checking your ordering. So if you're concerned about the ordering and how it's going to output your order, this is actually a really good way to determine that, because I can see here exactly the order that the G code is in, so I can tell how it's going to cut this job. And so if you want to re-verify the ordering that you set up, so let's say you set up a kind of a complex ordering system to make sure that it does everything correctly, you could double check it through backplot, make sure that it's doing it correctly before you send it to the machine. If you see an error here, then you can go back into EnRoute and correct your ordering to make sure that it comes out properly.
All right, got a couple more questions here. First one is, how would you add a perimeter cut for the 4 panels so the machine is making clean edges for the panels to meet up?
That's a good question. So in that particular case, what I would probably do is I would probably just create some geometry to do that. So I would probably just create, and the good thing is here is if we're doing something like that, I can take, I just draw a rectangle, give it my size, so 192 by 96 in this particular case, and I could simply place it on screen. Let's see here. No, I want this one. I could just place it on screen, and then I could grab this and hit Control 5, and that'll pop it right into place. And then all I would need to do is draw another line here, and then probably another line using, and I would, in this particular case, I'd use my snap tools. So I'd use the snap to midpoint, and then just draw a line here. So I could just snap it there to there, and then snap there to there. And then I would just create a perimeter cut on this one, and then just 2 engraved cuts right down the middle. Or you could use an open offset contour to make sure that it offsets to the correct size. So an engraved probably actually wouldn't be the best idea. An open offset contour would be the best, because it would give me the option to put it to the left or to the right, so that it actually wouldn't carve into the design. It would just give me a clean edge. So that would probably be the best way in that particular scenario.
Awesome. And then next question is from Tim. Is there any limit to the size of the ultimate project or the number of panels that can be made from?
Not particularly. There are, at least as far as I know, you can just kind of go crazy with the amount of panels you want to put in here. I don't think there's a hard limit. The only size would be, yeah, I honestly think it would just probably be unlimited. If you were doing it in this way, where you're basing everything off of a specific panel size that you could readily just plop on the machine, that makes this really easy. If you're having to move the sheet around, that makes it a little bit harder, but still easier, but still, a little more tricky. But yeah, I don't think there is a limitation. The only thing that you would have to consider at that point is, how big is the file, and things like that, which EnRoute 64-bit version of EnRoute 7, since it is 64-bit, it can handle a lot more than it used to be able to. So, you're gonna have a lot better opportunity to do that kind of stuff. And even with this kind of stuff here, like we're talking here, this is a fairly easy thing to do. Even if the design were a little more complicated than this, I would say that toolpathing and vector cutting is really easy, like in terms of scaling it to larger sizes and things like that. The tricky thing will be if, let's say that you wanted to create a 3D panel that was maybe, say, twice the size of this. You might run into some problems with that, just because 3D takes up a lot of memory and a lot of processing power. So you might run into problems with that. But, even with rapid texture, you might run into an issue if you got way too big. Then if you're going to get into that sort of let's say you're going to do a massive wall. I would probably just create a symmetric texture and then just repeat it a bunch of times. So if especially if I was using rapid texture, or if I was building a wall with a 3D texture, I would probably just create the 3D texture. And let's just say I was using 4x8 panels. I would just create it in the 4x8 and then just make sure that that was a repeatable pattern. Now, sometimes that's not always possible, right? So some scenarios you just have to try it. But now that EnRoute 64-bit, there's, you're a lot less limited in terms of resources. And then as far as the limitations of the software is concerned, there's no limitations set on you. I think you can put as many panels as you want, and you can make it as big as you want. It's just you might run into, like I said, with 3D or with rapid texture, you might run into some memory problems or processing problems. So that might only be the limitation, but none really that I can technically foresee.
All right, and then Bill's got a couple questions here. First one is he's asking if you can quickly describe scenarios where you would use the other settings for the plate in the machine settings.
Yes. Okay, so let's see here. Let's go into driver selection here. Most of these other settings I don't particularly use because it gets a little confusing on how to use them. So user defined is basically always the plate. So if I click on that, it's always based off the plate. So no matter how many panels I have or anything like that, it's always based on the red boundary plate. And so no matter how big I make this or small, it's always going to be here. And that's kind of that setting. Obviously, plate sets it to the plate. So what I can do is I could actually theoretically move the plate around into a different origin. So for example, if I go to my plate, define plate, I could mess with the origin of the plate. I go negative or positive with that, and I could move the origin of the plate around, and then it would move the origin based on where the plate is. So you could use that. That's how a scenario where you could use the plate option that's not related to that particular tool. Kind of rare, mainly because that can have a severe effect on how your machine handles those values in terms of your X and Y, because most machines have they use positive X, positive Y, or they might use positive X, negative Y, or negative X, positive Y, or they might go negative Y, negative X. So it kind of depends on which zone of the quadrant that your machine is operating in. And so typically all that's handled in the driver. It used to be handled that you could handle it in here, and that's why we kind of took it. We stopped using it. We started setting in the driver because it became kind of confusing, even for the techs, to be able to handle it. But design, this puts it basically at the beginning of the origin, basically at the beginning of your design. So the confines of your design. So, and it takes a while for the screen to pop up. So I'm just going to move this out of the way for a second. But so your origin then would be, in this particular case, would be down here somewhere. And that's based off of when you highlight it. Actually, I'm going to have to close that anyway. If I highlight it, this is most likely going to be your origin somewhere down in here. So you could do it by design. And then the last one was, let's see here, by selection. So, okay. So this one is going to be by specific selection. So the difference here and here is going to be is if you select a certain set of objects versus the entire design. So I believe this will take in consideration stuff that's outside the plate and make that your home. And then this one will be just what you select. Again, it kind of becomes a little confusing as to why you would use one or the other. 90% of the time, user-defined or plate are the only ones that we would use. Once we get into the other ones, it kind of becomes a little bit more complicated, because most customers just want to use, they want to know, have kind of a consistent place where it's always going to put the origin. And user defined and plate, those two settings kind of do that. It gives you a consistent place where you always know, okay, this is where it's always going to be, versus having to guess or assume, because there's no visual per se that tells me that's going to be my origin, like you have with the plate or with the user defined. With the user defined, it'll always be here. With the plate, it'll always be whichever plate you have selected. In this case, there's only one plate, so I have one. Whereas if I use this other tool, then I can choose which plate I want to have as my origin. Yeah, Bill. Yeah, I'd say leave it alone. Right. It becomes too complicated. Yeah. You could probably mess around with it and here's what you could do is if you kind of really want to see how it affects your machine specifically, because your driver is also going to have a slight effect on some of that. And so yours might not look exactly like our typical example here. Like I said, your origin could be shifted up here or up here based on your driver. So maybe a good test would be you can use backplot to actually verify, what some of that stuff does. So maybe create something, change it, output it in backplot, and then open it up in backplot and see, hey, what does it do to my origin? And look at the XY coordinates. You'll see here, here's your first starting, and we're in positive territory. What does it do in relationship to everything else? Does it move this out of the way? Does it move the design up and keep this in position? Or does it keep the design in position? Does it move the origin out of the way? So it's kind of an interesting thing to do, but might be worth looking into. It's by case scenario. But those are kind of what I know that they do. I would probably, if you're considering using them, I might just double check with your machine and just test it out. It's not bad. And Backplot gives you that ability to do so.
Awesome. And then Bill has another question. Can you make individual files out of a bunch of panels created this way to avoid memory problems with 3D?
Yes, you can do this with 3D. Yep. You still have to be able to create the panels in 3D in its entirety. But when you go to output, it will be easier on the output engine. Another good example of that follows along that same comment is some machines out there actually do have a G-code line limit. I've seen this before. Not a lot of machines, but a few. And I think they're older machines with specific controllers. But I have seen machines run into actual line limits and say, nope, you've got too many lines of code, and it just actually starts to cut them off. Or the machine just won't load the rest of the file. It gets to a certain line number and stops cutting. So if you're running into that problem, even if you're doing a relatively small 3D job, using the panels is a good way to split the cut into several parts so that your machine can actually execute. You don't even have to move the material around. It just cuts the first quarter, second quarter, third quarter, fourth quarter, and then you're good to go. So, that might help in terms of people who are struggling with that kind of issue as well. But in terms of laying down the 3D, you're still going to have to lay down the 3D panel. And that's where it depends on the file. If you're just doing like a big wall of symmetric panels, it's all going to be the same texture, but just symmetric. That's where I would go into your symmetric paneling options for like surfacing. And that's where we have textures. We've got regular textures, and then we have symmetric textures that are perfectly symmetrical. so that you could actually just make one panel and then just make a bunch of them, and then they will all fit together because they're symmetrical. Same thing with rapid texture or and things like that. You have options in there to make it symmetrical so that you don't have to create a huge wall worth of the same texture. Now, again, if it's a unique texture that doesn't stay the same, you might want to consider breaking it up, and that might help.
All right. Are there any final questions before we close it out for the day? Had some good ones here. Thanks everyone for participating. Makes it a little more fun for Aaron, I think, if he gets challenged a little bit.
Also, just a note also on Bill's question there, the memory in EnRoute can now, because EnRoute 7 goes 64-bit, it has the option for more memory. So if you're running EnRoute 6 and struggling with 3D, a 7 would be worth the upgrade, because it allows you to go more than just 4 gigs of RAM. So a big plus for if you're doing 3D or rapid texture. So just so you know.
All right. Doesn't look like there are any more questions coming in, so we'll close it out for today. Thank you all for joining us for this EnRoute webinar. Our next EnRoute webinar will be about using layers in EnRoute, which will be kind of the lead up to the webinar following in the next month, which will be about creating a 3D sign from start to finish. So next month's will be on June 14th, and we hope to see you there. We'll have the link to sign up for that in the email with the webinar recording that you'll receive later today. Make sure you're subscribed to our newsletter so you won't miss out on any webinars or other announcements. You can sign up for that on our website. Thanks again for being here. We hope you learned something, and we'll see you next time.